So here we have a problem written by Ankan Bhattacharya. A hexagon ABCDEF is inscribed in circle omega with center O. Diagonals AD, BE, and CF intersect at P. Suppose that angles APB equals CPD equals EPF, and AD plus BE plus CF is 38, and the area is 85 rad 3, and the length of OP is square root of 74. Compute the radius of omega. So first, the most important claim that we have is that AP plus CP plus EP is equal to BP plus DP plus FP. So how are we going to go about proving this? So first, we draw in the midpoints of AD, BE, and CF, and we call them X, Y, and Z. So notice that since they are the midpoints, then OZ is perpendicular to CF, OX is perpendicular to AD, and OY is perpendicular to BE. And notice that because of these perpendicularities, then X, Y, and Z all lie on the circle with diameter OP. So next, without loss of generality, suppose that Z and P lie on opposite sides of XY. And X is on segment AP, Y is on segment EP, and Z is on segment PF. And the reason we can assume this without loss of generality is because we can always rotate the point names or reflect them such that this statement is true. So now that we have this statement, we have that angle XYZ is equal to angle XPZ, which is 60, and angle YKZ equals YPZ is equal to 60. And the reason that both of these angles are 60 is because we have the initial condition that APB equals CPD is equal to EPF, and by the vertical angles, these three angles are also equal to the other three angles APF, BPC, and DPE. And since all six angles are equal and they form a complete 360-degree rotation, then each angle is 60 degrees. So therefore, XYZ is equal to YXZ, which is equal to 60 degrees. That means that this triangle here is equilateral. So next we have, since XYZ is an equilateral triangle and P is a point on their circumcircle, then by Ptolemy's theorem, we have that PX plus PY is equal to PZ. And if we multiply that equation by 2, then PX is equal to AP minus DP, PY is equal to EP minus BP, and PZ is equal to FP minus CP. And so now we have this new equation here, and once we subtract over the terms and make it into the equation that we have at the beginning, our original claim, then we see that we have AP plus CP plus EP is equal to BP plus DP plus FP. And we know that the sum of these two expressions is just AD plus BE plus CF, which by the problem statement is equal to 38. So therefore, each of these two expressions is just half of 38, which is 19. So now we have proved this crucial claim. So now how to continue, we have 19 squared is equal to the product of these two expressions. And if we expand this product, then we can divide it into two different parts. So AP times DP plus BP times EP plus CP times FP. And notice that each of these three expressions is just the power of the point P with respect to the circumcircle of the hexagon. And next, the other part is AP times BP plus BP times CP, all the way down to FP times AP. And notice that by the formula for the area of a triangle, which is 1/2 AB sine C, then the area of triangle APB is 1/2 times sine of 60 degrees times PA times PB, which is square root of 3 over 4 times AP times BP. So therefore, we have that the area of the entire hexagon is just rad 3 over 4 times the sum of the products of each adjacent pair of segments from P. So this means that the expression becomes 3 times the power of the point P plus 4 over square root of 3 times the area. And if we simplify this expression, then we have 3 times the power of the point P, which is equal to r squared minus 74, since OP has length square root of 74. And the 4 over square root of 3 times the area of the hexagon would be 340. And this expression is equal to 361, which is 19 squared. And simplifying this, we get r squared equals 81, which means r is equal to 9. So therefore we have that the radius is equal to 9.